Hello everyone, good evening. So my team and I have conducted a research in evaluating AI agents to solve the blackjack problem. The layout of the following presentation is as follows. So the first AI algorithm implemented was the Evolutionary Neural Network. The architecture is made up of a combination of a genetic algorithm and a simplex neural network, and as an activation function we decided to make use of the sigmoid function. The network is provided with 4 inputs, 1 hidden layer of size 100 neurons and 2 outputs. The generation size was initially set to 20 and the mutation rate to 0.05. Every network is a representation of a player in a blackjack game. Its performance is measured on the winning rate, chips left within the bank, and rewards received. The second AI algorithm was the genetic algorithm, and the implementation of our genetic algorithm involves a gene of an individual, which is used to represent a decision given a state. If genetic structure is represented by rows and columns of possible hands a player can be dealt with, and all the possible up cards a dealer can have, respectively. This approach overcomes hardware limitations and approximates the most optimal strategy. Training a genetic algorithm is expensive since you're calculating the fitness function which the population requires to play a great number of rounds. Each generation plays 10,000 rounds. The most optimal strategy is the one which ensures the most amount of money earned at the end. The following are the hyperparameters and selection methods implemented. Our final machine learning algorithm was the Q-Learning. So for our Q-Learning implementation, we adopted a state structure tuple consisting of the player's hand value, a boolean indicating whether the hand is soft, a boolean if the hand is splittable, and the dealer's upcard value. We implemented a system to keep track of the hand's value due to a limitless number of splits through decisions which are stored in a list denoted as an episode. After every player's turn, the value function is applied to reward each decision in every episode. The training performed over 1 million rounds of blackjack to ensure most hands combinations are encountered by the agent. Betting strategy is constant. At the start of every round, the agent bets 1 chip. If the player loses, the reward in the Q-Learning value function is taken to be -1. If it draws, it's taken to be 0. If he wins, it is taken to be 1. And finally, if he wins after doubling down, the reward is valued as 2. Then we performed evaluation. So we performed 2 sets of evaluation procedures. The first one was evaluating the algorithm separately. Every algorithm that uses 3 candidate hyperparameter solutions which performed best under the following 3 ordering criteria. That is, most wins, least losses, and best net chips. After we selected the best trained agents of each algorithm, and it was fitting to see how these compare to one another. These were compared to an agent which was playing using the black basic strategy. The latter acted as our gold standard since basic strategy is known to be the optimal strategy for blackjack. The algorithms were also compared to 3 baselines, which were mimic the dealer, never bust, and random strategies. The results show the GA and the Q-Learning approximate the closest to the basic strategy, while the ENN doesn't perform as best. However, all 3 algorithms compared better than some other baselines. We finally implemented a simulation, a Unity simulation that made use of the pulling lever method, whereby we fed in Unity the blackjack strategies produced by each model, and each action which resulted from its respective strategy. This included a stand, double, hit, or split within Unity. The 2 gameplays provided till now are the user versus the dealer and the AI versus the dealer. Future implementations will include having the player play against the dealer alongside other AI agents. So, to conclude, throughout the study we explored various machine learning techniques so as to determine their ability to be applied to the domain of learning the optimal strategy for blackjack. The research conducted further shows that this problem can be learned using machine learning due to it being stochastic in nature. Future work will involve including card counting as well as improving certain architectures such as the ENN to achieve better results. We also conducted some experiments on our implementations of these algorithms and presented the observed data. We were also able to conclude that the genetic algorithm implemented approximated a better strategy. Thank you.